Hi, everybody. Welcome to our very last lesson of our quadratic functions unit. We are going to talk about one last form today, and this form is called root form. So we can take a quadratic equation and we can convert it into this root form. And the reason why this is useful is because we can look at it and we can automatically know what the roots are or the x-intercepts. So that's what makes this form useful. Now, just like the previous lesson where we were writing equations in vertex form, it's important that we have our A term, because if we don't have our A term, we really don't have the specific parabola that we're talking about. So I don't know if you guys remember when we did questions where I would say, okay, the roots of a quadratic equation are x equals 2 and x equals -1. And I said, can you work backwards to tell me what the equation of that parabola could be? And so what we do is we'd say, oh, well, x equals 2 came from x minus 2, and x equals -1 came from x plus 1. And then what we would do is we would FOIL that, we would distribute, and we would get this quadratic equation. So that is one possible quadratic equation that has those two roots. But one thing that we didn't talk about is that there's an infinite number of parabolas that have those two roots. Okay, so for example, if I was to look at a graph of this, let me just get rid of this here. Now I'm forgetting what my roots were. I think it was -1 and 2. Okay, so here's one parabola that has roots of -1 and 2. Okay, but I could have also made a parabola that looks like this, right? I could have also made a parabola that looks like this. And so all three of these parabolas have the same roots of -1 and 2, and what makes them unique is what our A term is. Okay, so that's why it's so important that when we go through and we write this formula, that we know what our A term is. Okay, it actually tells us how narrow or how wide our parabola is. And we haven't learned about that yet, but I wanted to point that out as we're going along. Okay, so looking at the very first example here, you can see that we are given the x-intercepts of 3, 0, and 5, 0. Now, the additional information we have is that it passes through the point 1, 7. So again, the reason why it's important for us to have that additional point is because that will tell us what we need to use in order to find the correct A term. Okay, if we didn't have that point, we would go through that process just like I showed you, where we work backwards and we figure out what our equation would be if A was 1. Okay, so what we're going to do is something similar to vertex form. We're going to plug in all of the information that we're given. So looking at your x-intercepts, these are going to be represented by our R1 and R2 in our formula. Okay, they're considered our roots, and so we're just going to say this is my first root and this is my second root. Now I don't have to worry about the zeros, the y-coordinates, because they're always going to be 0 in an x-intercept, so it's really the x-coordinate that I care about, making R1 and R2. Now, the other point that we have here, that is going to be our x and y. Okay, so it's a point, has an x-coordinate, has a y-coordinate. So now if you look back at our formula, we have everything we need to substitute in except for A. And so just like in vertex form, A is what we're going to solve for. Okay, so let's start plugging some things in. I know from my point that y is 7. A is what I don't know. I know from my point that x is 1 minus my first root, which we said was 3, times 1 again, minus my second root, which is 5. Okay, so that's how I go about plugging in those values. So then what we're going to do is we're going to simplify. So 1 minus 3 is -2. 1 minus 5 is -4. Then I'm going to multiply. -2 times -4 is +8. So this is really positive 8a. And solving for a, I'm going to get that a is 7/8. Okay, so to write this in root form, we go back to our formula, but we use y equals the a that we just found, 7/8. And then in the parentheses are really just showing what your roots were before they were solved, if that makes sense. So, for example, this would be x minus 3, because that's where I got a root of 3. And this one is x minus 5, since that's where I got a root of 5. And that's your final answer in root form. Okay, so let's try another one. Number 2, again, we're given the x-intercepts, and we're told that this parabola passes through the point -4, 15. Okay, so again, root 1, root 2, x-coordinate, y-coordinate. So a is what I don't know. All right, so in place of y, we're putting 15. A, x is -4 minus the first root, 2. X again, -4 minus the second root. And then I'm going to simplify my parentheses. So -4 minus 2 is -6. -4 minus 1 is -5. This would give me positive 30a. And so when I divide, 15 divided by 30 is 1/2. Okay, so if a is 1/2, I can go through and I can see here y would equal 1/2 times x minus my first root of 2 and x minus my second root of 1. Now, if either one of those roots were negative, we would be doing like x plus 2 or x plus 1. It just happens that they're both positive and the formula is x minus the root. Okay, so I think in the next one we'll see that happen. All right, so number 3, we have x-intercepts being 3, 0 and -4, 0. So there's my root 1 and root 2, and it passes through the point 2, 18. So there's my x and y. All right, so y equals 18 equals a times x is 2, so 2 minus the first root, which is 3, times 2 minus the second root, which is really 2 minus -4, so that's going to be 2 plus 4. Okay, we'll simplify. -1 times 6, so this is going to be -6a. And when I divide, I get that a is -3. All right, so y equals -3 times x minus 3, and then this would be x minus -4, so that's just x plus 4. Okay, so just looking at that really quick, remember, because that a term was negative, it means that our parabola is opening downward. Okay, where if you look at numbers 1 and 2, both of those a values are positive, so those were opening upward. All right, let's go to number 4. So again, we have our x-intercepts, so there's R1 and R2, and the point that it goes through, xy. All right, so y equals 33 equals a times x is 4, first root is 5, times, again, x is 4 minus the second root, so minus -7 is going to be 4 plus 7. Okay, so a times -1 times 11, so we get -11a, which means a is -3. Okay, so to write our final equation here in root form, y equals -3 times x minus 5 times x minus -7, which means it's x plus 7. Another parabola that's opening downward. Okay, so now we just have a bunch of review questions based off of that parabola. So this will be good to kind of end our unit. So it says for part A to write your answer to number 4 in standard form. Okay, so remember, standard form of a quadratic equation looks like this, where it's y equals, and then it goes in order of ax squared plus bx plus c. Okay, so my suggestion here is probably to go ahead and simplify your root form equation by distributing. Okay, and it should automatically end up in standard form. So let me just rewrite what we got for root form here. Okay, so because all three of these things are being multiplied together, you can multiply in any order. The commutative property says you could do -3 times x minus 5 first, or you could do x minus 5 times x plus 7 first. It really doesn't matter the order. I am going to choose to multiply my two binomials together first. Okay, so I'm going to just bring down my -3. And so when I multiply those two binomials together, I'm going to get x squared plus 7x minus 5x minus 35. And then before I distribute that -3, I'm just going to combine like terms here to get 2x in the middle. Okay, so my last step is to actually go ahead and distribute the -3. So -3x squared minus 6x plus 105. So that is my standard form. Part B says to write your answer to number 4 in vertex form and then identify the vertex. Okay, so to write an equation in vertex form, remember we're looking at using completing the square to do that. So I'm actually going to go back to my standard form to do this. So I'm going to start with what I just got for part A. Okay, so if you remember how to start this, we have to make sure that our A term is 1. And since I have a -3 here, I actually need to factor that out. So I'm going to use a GCF of -3, which actually brings me back to this step right here before I distributed the -3. Okay, and then from here, this is where we're going to do our completing the square step. So we're going to take half of our B term and square it and add that. So half of 2 is 1. 1 squared is 1. So we're going to bring down that -3. And then inside the parentheses, I'm going to have x squared plus 2x plus 1. To balance it, I'm going to do -1 and bring down the -35. Okay, so what that gives me, -3, is now a chance to factor those first 3 terms. So what multiplies to be 1 and adds to be 2, 1 and 1. So x plus 1 times x plus 1, which we write as x plus 1 squared. And then -1 minus 35 is -36. Okay, so our very last step is to redistribute that -3 back into our equation. So -3 just goes out front of our x plus 1 squared. And then -3 times a -36 is a positive 108. Okay, so that is our vertex form. And then we also have to identify our vertex. So remember, we take out the h and the k from our equation to get that. And so h is actually going to be -1, because remember, my formula is x minus h. So when I take the h out, it's the opposite sign. And then k stays the same, so it's just positive 108. All right, this is great review. Part C, is the parabola facing upward or downward? So I'm pretty sure I said this right at the beginning of this problem. Because we found our A term in the very first part to be -3, or even looking back to when we wrote it in standard form, the a term there is also -3, that means that our parabola is facing downward. Okay, so when your a term is positive, that means it's facing upward. And again, downward means it looks like that. Okay, what is the domain of the equation? So if we think about domain, we're thinking x values. What's the furthest left and the furthest right that our graph goes? And with any parabola, we're going to have our domain be from -infinity to infinity. The range, so if you think about the range, remember that's how high and how low, because it's our y values. And because our parabola is opening downward, that means that there is a maximum point. Okay, there's a actual number that parabola reaches as its highest point. But its lowest point would be -infinity, because it just keeps going on in the downward direction. So if we start our range here, we know that the lowest value that y will take on is -infinity, and we know the highest value is whatever we said our vertex is. So if you think about right there, that's our vertex, and looking back at part B, we identified that point to be -1, 108. So which coordinate do I use? I use the y-coordinate because it's the range. So the highest point on that parabola is 108, and we include it because it's an actual point on the parabola. Okay, the y-intercept. So to find this, think about what a y-intercept means. It means that somewhere on the y-axis there is a point, and that point will have a y-coordinate that is 0. Okay, so if I were to go through, and I could just take my standard form if I wanted to, if I go through and I put a 0 in wherever I see an x, again, that's because any y-intercept has an x-coordinate of 0, I will get what the y-intercept is. Or some of you might remember that the c term of the quadratic equation is your y-intercept. Okay, so if you remembered that, you didn't even have to do any work. You just know that our y-intercept is 105 because that's our c term. But if you forget, you can put 0 in for x and you'll still get 105. All right, part G, find the y value of the equation when x is -3. So again, I would go back to standard form. And if I need to know what y is when x is -3, I'm going to substitute in -3 wherever I see an x. Okay, so let's do some simplifying here. This is -3 times 9 plus 18 plus 105, which I'm getting 96. Okay, so that is the value of y when x is -3. Now, another way that you could have done that is you could have put this equation into your graphing calculator on a graph, and you could have pulled up the table, and you could have looked at the table for where x is -3 and saw that y is 96. Now, obviously, that's not showing work, and so I would use that as a check, and you'll see that you get that same y value. All right, last question. What is the vertex, and is it a maximum or a minimum value? Okay, so we've already identified the vertex in part B. We said that it was -1, 108. And we've talked about how this parabola opens downward, meaning that there is a maximum point. Our vertex is our maximum. Okay, if the parabola was opening upward, there would have been a minimum point, and our vertex would have been that minimum point. All right, guys, great job learning from home with this unit.